Welcome to another physics video. Today we will be doing the homework for chapter 4 on friction and net forces. Before I begin, I would like to ask that everyone who is currently in a German class come in on Tuesday in a white shirt. I think it'd be quite funny. That's the closest thing you have to one. Alright, moving on with the video. I'm going to skip over a lot of the problems because many of them are very similar or are multiple choice, in which case I can't really help you through a video like this for concerns of cheating. I will start with the museum problems, which are going to use the force of friction is equal to mu, or the coefficient of friction for those materials, multiplied by the normal force. In all of these problems, there is a horizontal surface on which an object is being moved, which means that for all of these problems, the normal force is going to be the same as the object's weight because it's asking for magnitude. So for all of these museum problems, the normal force is going to be the mass times gravity, which is also here mass times 9.81. Which means that for these problems, your answer is always going to be the friction coefficient times mass times 9.81. So I will show you my problems 12 and 13. So for me, 12 is aluminum on steel static, which is 0.61 multiplied by 172 times 981, which is going to be equal, 9.81, which is going to be equal to 1029.265. Now next, I'll do 13, which is going to be aluminum on steel kinetic friction, which is 0.47 times 172 times 9.81, which is equal to 793.04. You can apply this logic for all the problems that you'll do for these museum questions. Okay, next I'll do the question about the bear, which is question 10. So here's my tree trunk, and this is the bear sliding down the tree trunk. The question says that the bear is going at a constant speed, which means that he's not accelerating, or she. Given the bear's not accelerating, that means that the net forces are going to be 0. So the force downwards, or the weight of this bear, is going to be 531 times 10. And for the net forces to equal 0, the force of friction pulling the bear back up also has to be 531 times 10, which means my answer for this question is 5,310. Okay, question 11. So this is the question about the crate. So the crate is being moved on a horizontal floor. The crate weighs 21 kilograms. There is a 55 Newton force that keeps it moving at a constant speed, which means that the net forces are again 0. So the force of friction, in this case, is also 55 newtons, because remember, the crate is not accelerating, which means the net forces are 0. So the force of friction is equal to mu multiplied by the normal force. So the force of friction is 55 is equal to mu times 21 times 9.819, which is the normal force, because gravity is going to apply, because of gravity, this crate is going to weigh 21 times 9.81, and the normal force, because it's horizontal, is going to be the same thing, 21 times 9.81. So this is 55. So here the answer is going to be, so the answer for this problem is going to be 55 over 21 times 9.81, which is equal to 0.267. And finally, the wonderful, I don't know, but 0.9, here, 9. And finally, the wonderful cyan block problem. So this one's pretty interesting. So the first step is going to be, you're just going to draw this little ramp here that it's going down. Here's the block. Here you have gravity, friction, and the normal force. Looking something like that. So next, what I'll do is I will what I'll do is I'll add some more to this drawing. So I have 25 here, and this block is traveling, sorry, not traveling, it's accelerating 3.5 meters per second squared. Okay. So what you'll want to do is you'll want to take this gravity and split it up so you can find the normal force. So here's the block. So we're going to split it up to have a force that's going this way, a force that's going, I guess, this way. Oh, whoops, this way. And this is the gravity force I'm trying to split. So these should make a triangle that looks something like this. So here's the right angle, and then this is 25 degrees as we're given. So the downwards force of this block is going to be, so this here is 9.81 m. I'm saying that m is the mass of this block. So next, you'll want to use trigonometry to find these two sides here. So yeah, this is also that. So to use trigonometry to find these two sides, you'll have the cosine of 25 degrees is equal, I'll call this side, let's say, I don't know, I'll call this side call this side n, for example, over 9.81 m. So n is equal to 9.81 m cosine of 25, which is also equal to which is also equal to 8.891 m. Now this one, I don't know, I'll call O. So O. So sine of 25 equals O over 9.81 m. So O is equal to 9.81 m sine 25. Which is equal to 4.146 m. Okay. So this means, now that we have the force of n, that is also going to be the same as our normal force. So this is also equal to the normal force. Now, remember, the final force of this whole thing is this arrow. So this is its acceleration, but its force is its acceleration times its mass. So this force, which is the one that the whole thing results in, is 3.5 m. So I'll say this is the resulting force. So we know the normal force, we know the resulting force, and we're trying to find mu here. We also know the force of gravity that pushes this block in this direction. So here what happens, what we have on this block now, if I draw it again, we have the force of friction pulling it back, force of the total force of it, like going forward, and the normal force. So these two forces cancel out. That's this one and the normal force. This is gravity, so this has been broken up into two parts, so it does not have to be drawn here. I've added friction now, and the other component of gravity. So gravity cancels out with the normal force, and gravity also has to work against friction to move the box down at an angle. So we know that the total force, we just have to say that total force is equal to this force that we got here. So F of like G, I don't know, something, because the force of gravity would be this one. So I'll say that this one's F of G O, for example, minus the force of friction. So we know that this force is 3.5 m is equal to 4.146 m minus this force of friction. And the force of friction is mu times times the normal force, which is 8.891 m. M cancels out for all of this, so no more m to worry about. And then all we have to do is subtract this. So 3.5 minus 4.146 over negative 8.891 is equal to mu, which is also equal to, one moment, which is also equal to 0.073, which gets you the answer.